All right, everyone, let's go ahead and take a look at motion in a straight line part 2. What we're going to do again is we're going to take a look at how we can analyze functions using the first and second derivatives. So let's go ahead and just say that we have a particular function, and let's say that this function is s of t is equal to t squared minus 4t plus 3. And of course, let's say that time is greater than or equal to 0. So what I have here is I've graphed it for us in 2 dimensions. Notice that this is t, and notice that this is s of t here. Now I'm only going to go ahead and draw this up to t is equal to 5, because otherwise it'll just continue increasing that way. So what I have then is that if I let t be equal to 0, of course that's going to be 3. If I let t be equal to 1, it's going to have a distance of 0. If I let t be equal to 2, it's going to have a distance of -1, and so on. Now remember that what we did in the previous lesson was that we wanted to take this information that's in 2 dimensions, and we want to change it so that it's in 1 dimension, and we want to change it so that it looks like a motion graph. So let's go ahead and just see how this particle is moving in 1 dimension. So notice that when t is equal to 0, the position is at 3, right here. And then when t is equal to 1, the position is at 0. So notice that the direction that the particle is moving is that direction. Okay, notice also that from when t is equal to 1 to t is equal to 2, the particle goes from 0 to -1. So notice that the particle is going this way. Okay. And then after that, from here, the particle is going to retreat back to 0. So it's actually coming this way. After that, from 3 to 4 seconds, it is going to go all the way back to the position of 3. So notice that it goes like that. And then, of course, when it goes from 4 to 5, the position is going to be all the way at 8. So let's just get a feel for what that looks like. And I'm just going to try to keep a constant pace of time so that we can kind of get an idea of what's happening with this particle. Now let's say, for example, that this particle is the tip of this green pen. Okay, you ready? Here's what you have to take this is what you have to imagine that the particle is doing. Ready, set, go. 0, 1, 2, 3, 4, 5. Okay, that's how the particle is actually moving. So what we're going to do now is we're going to also be able to analyze what the particle is doing in terms of its velocity and its acceleration, because we already know that the velocity is the first derivative of the distance function, and the acceleration is the first derivative of the velocity function, or the second derivative of the distance function.